At Longhorn Racing, not only do we build the best race cars, but we're building the future generation of engineers. Longhorn Racing is a student-run organization here at the University of Texas at Austin, and we design and manufacture race cars. We have 3 teams, a combustion team, electric team, and a solar team. And each team fully dedicates a whole design cycle, whether that is a year or maybe a 3 to 4 year cycle, in designing and manufacturing these vehicles for their specific competitions. The electric vehicle is one of our most recent teams, founded in 2016, and our electric vehicle is designed in the fall semester and manufactured in the spring semester, and it is approximately ready to go for competition in July.
The electric vehicle is composed of 5 systems: aerodynamics, body, dynamics, electronics, and powertrain. So each of these different systems handle different parts of the car. Each of those systems also have different subsystems. So within each subsystem is where our members lie, and we have subsystem leads, a chief engineer, and a team captain. And all of us work together cohesively with our operations team to build the electric vehicle. Longhorn Racing, I think, is really special because, as I said earlier, we are a completely student-run organization.
Some of the challenges we face in designing an electric car is trying to make it go as fast as possible, making sure it's sufficiently cool so that the battery doesn't blow up and cause other problems, and do that in an effective way so that we don't have to spend hundreds of thousands of dollars creating actual physical models. And that's where Cadence and CFD really helps us out in that design process.
The biggest safety challenge that we have is just time consumption. The simulations take a long time because we're doing simulations on aerodynamic devices on the car, from the wings to the under tray to the tire rotations. These simulations require meshes that have millions of cells, and then we have to run the simulation on the mesh itself. So it's kind of like a double whammy of how much time gets consumed for each simulation run, and we have to do this multiple times for each iterative design. Another challenge we have with CFD is just ensuring our results are accurate and comparing that to real-world data, because we don't have any wind tunnels or anything large enough to house our vehicle. Cadence CFD comes in to save the day, as it takes a relatively short amount of time to run simulations compared to other softwares or just in general. It's a cloud-based software that allows us to pretty quickly get our models in, mesh them, do the simulations, and rinse and repeat.
Cadence's software package is really easy to use, and it's a great way for a lot of our newer members that haven't had experience with anything near the scale of CFD to just like get their foot into the door and get experience doing CFD. And it's really easy for them to follow the steps and develop a simulation that will like work. And that's really exciting for them to see their first simulation run and not crash.
Cadence CFD definitely helps us with our meshing process with computational time. A lot of their software helps us develop our COP targets, develop our wing targets, tell us exactly how much downforce each wing is producing, and help us balance our COP CG targets to make an overall stable car.
With Cadence OnCloud, we have access to 32 cores per each simulation, so it enables our CFD simulations to be much quicker as compared to our personal laptops. They only have 12 cores, so you can imagine how much quicker these simulations and meshes can take.
Our relationship with Cadence is able to help our members out by giving them real-life experience with software that they will be able to use in their internships and their full-time jobs.
Longhorn Racing Electric is getting the next generation of engineers excited about electric vehicles and designing electric vehicles. So hopefully when they're out in the real world making a real-world impact, they're doing it on sustainable transportation.